Today, we're going to pull back the curtain on one of math's best-kept secrets. We're talking about these powerful shortcuts called algebraic identities that can make some really complex-looking problems, well, incredibly simple. Okay, let's just jump right in with a little challenge. Take a look at this, 107 times 93. Can you do that in your head? No calculators, come on. It seems pretty tough, right? Go ahead and give it a shot. Just keep whatever answer you come up with in your head. Well, what if I told you there's a kind of secret code in algebra that lets you solve this in literally a few seconds? That's what we're diving into today, figuring out how to turn these tough-looking problems into simple, easy arithmetic. So here's the game plan. First, we'll get clear on what an identity even is. Then, we'll check out a set of 4 essential formulas, level up by mastering squares and cubes, and finally, we'll put all these awesome new tools to work. All right, section 1, what in the world is an identity? You know, the best way to think about them is as the unbreakable, absolute rules of the algebra game. So here's the key thing you gotta remember. An identity is an equation that is always 100% true. It doesn't matter what number you plug in for the variable, the left side of the equation will always equal the right side, every single time. And what's so cool about this slide is you can see it in action. Look at that equation. A plus 2 times A plus 3 equals A squared plus 5A plus 6. It doesn't matter if A is 2 or 5 or even a negative number, like -8. Both sides of that equation will spit out the exact same result. It's a perfect constant balance. Okay, so let's get into our next section and see how this actually helps us. It's time to get our hands on our very first set of practical shortcuts. In algebra, these are often called special products. So this table lays out 4 really foundational patterns. Now I know they might look kind of similar, but you gotta pay close attention to where those plus and minus signs are. Really understanding these patterns is the first big step to unlocking way faster calculations, and it saves you from having to do long, boring multiplication every time. All right, you've got the basics down. Now it's time to seriously level up our toolkit by mastering 2 of the most famous and, honestly, most useful types of identities out there, squares and cubes. I'm willing to bet you have seen the formula for a plus b squared before. It's got to be one of the most famous identities in all of math. But have you ever really stopped to think, where does it even come from? It isn't some random rules somebody just made up. And this slide just breaks it down so perfectly. Squaring something? That's just multiplying it by itself, right? So you multiply a plus b by a plus b, combine the like terms in the middle, and there it is, a squared plus 2ab plus b squared. See? No magic at all, just straight up logic. Now check this out. Look at the comparison between squaring a sum and squaring a difference. They're almost identical twins. The only thing that's different is that little sign in the middle, on the 2ab term. That one tiny detail is literally the only thing separating them. And just to round out our core toolkit, here are the identities for cubes. Yeah, they look a little scarier, but they come from the exact same thinking, and they are incredibly useful for some of the more advanced problems you'll run into. Okay, this is where it all comes together. We've got the theory down, we've built our toolkit of formulas. Now for the really fun part, seeing what these things can actually do when we put them into action. Hey, remember this guy from the beginning? 107 times 93. It probably seemed like a real pain to do in your head before, but it's about to get super, super simple. Why? Because now we have the secret code. So the whole trick here is about how you look at the problem. Instead of seeing 107 and 93, try to reframe them around a nice easy number like 100. So the problem is really just 100 plus 7 times 100 minus 7. And the second you write it that way, a light bulb should just go off in your head. Hey, that should look familiar. It's that classic pattern we just learned, the product of a sum and difference identity. A plus b times a minus b. And because we spotted that pattern, we know the shortcut. The answer to a plus b, a minus b is always just a squared minus b squared. All those middle terms just cancel each other out, leaving us with something way, way simpler to calculate. And this is math we can all do in our heads, right? 100 squared is 10,000. 7 squared, that's 49. Do a quick subtraction and boom, 9,951. Just like that. How cool is that? But listen, these aren't just for cool party tricks or mental math. Their real power, especially in algebra, is helping you solve puzzles, finding missing values when you only have a couple pieces of the puzzle. Okay, take a look at this one. You're told that two numbers add up to 8, and when you multiply them, you get 15. The question is, what's the sum of their squares? Man, without identities, that is a really tough nut to crack. But now we have a plan. We can grab that identity for a plus b squared because look, it's got everything we need. It has the a plus b part that we were given, it has the ab part, and it has the a squared plus b squared part that we're trying to find. It connects all the dots. So from here, the solution is actually pretty simple. We just plug in the numbers we know. So 8 squared equals our mystery value plus 2 times 15. You just move things around a little bit, and the identity basically just hands you the answer. It's 34. So you see, from mental math shortcuts to cracking these tough algebraic puzzles, these identities are an absolutely essential part of any math toolkit. And it really makes you wonder, right? Now that you know these secrets, what other math problems that you thought were hard suddenly start to look pretty darn easy?